All right, now we are doing part C, which is going to be the limit as x goes to 0 of sine of x squared all over x squared. So now this is once you see sine of something, we don't care what it is. Once you see sine, you know it's from -1 to 1. So it's less than or equal to sine of x squared, which is less than or equal to 1. Now what are we doing? We are dividing it by x squared. That's what you do to all of these guys. So it's going to be -1 over x squared. It's less than or equal to x squared sine x. Oh, sorry. It's less than or equal to sine of x squared all over x squared, which is less than or equal to 1 over x squared. Okay, this is negative of 1 over x squared. So now once we have this, we now have the range for this one, which is the one we're getting the limit for. Now we're going to get the limit on the left and the limit on the right, and it's obviously going to be for this one. So we can now say the limit is x goes to 0 of -1 over x squared. What is this going to be equal to? Well, are we able to substitute 0 in here? No, will become undefined. But we are going to get a value which is very, very close to 0. If we put it in here, we are going to get what? 0 times 1 divided by 0, you're going to get infinity. But there's a negative here, so it's going to lead to this negative infinity, okay? Then we can now say, what is the limit as x goes to 0 of 1 over x squared? Now we get for this one, okay? Which is going to be equal to, this just becomes 0 in the denominator and something very, 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 very close to 0. Okay, something very, 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 very close to 0. But remember here, we're getting something very, very close to 0, which may be negative or positive. But when we square it, it's going to become positive. So it's something very, very close to 0, but positive. And when you divide 1 by that positive, it will become infinity. But there's this negative here, so that's why it becomes negative. Then here, it's something which is very, very positive and very, very small, which can be negative. It's close to 0. It can be negative or positive, but when you square it, it becomes positive. So it's 1 divided by a very, 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 very small positive number is going to give us a positive infinity. And these two limits are not the same. Excuse me. So these two limits are not the same. You can see that they're not the same. Can you see that? So therefore we can say, since these are different solutions, we can say therefore limits cannot be solved by squeeze theorem, okay? Because they are different. So squeeze theorem is actually saying that there is no limit, okay? Probably, I don't know. But no, we can't solve it by squeeze theorem, okay? Although some other method may lead you to an answer like 0 or 1, but anyway, this is saying there is no such limit, because this is going to negative infinity, the other one is going to positive infinity, so it cannot be solved by squeeze theorem. Or we can say that this limit does not exist, one of the two, whatever. So, but basically, you have to get to this stage where you can show that they're not so we can't have a limit, this limit you are using squeeze theorem, it's impossible, all right? Now we go on to the next thing, which is part D.